Okay, this video is going to focus on equivalent forms of polynomial. The first part of this is going to review some of the topics that we discussed when we worked with lines, and then we're going to move into equivalent forms of quadratic equations, which will help us in our next unit when we're graphing and working with, standard form and vertex form of a quadratic. So, if we review a little bit here, we've talked about three different forms of a linear equation. All right, so point form, y equals m times the quantity x minus x1 plus y1. Slope-intercept form, which is y equals mx plus b. And standard form, which is ax plus by equals c. And so what we want to be able to do is work in between any of these forms of a line, or maybe convert from one form to another. All right, so if we look at an example here, all right, y equals 3 times the quantity x minus 4 plus 5. We should be able to take this and convert it to, all right, slope-intercept form and then on to standard form. And we've discussed this before that first thing we want to do is distribute. So 3 times x and then 3 times negative 4. All right, so y equals 3x minus 12, and then we're going to bring down the plus 5. Now we combine like terms. So y equals 3x minus 7. And now we are in slope-intercept form, just like that. So no big deal. Now, to get to standard form, what we know is that the x term and the y term are on the same side. So what I need to do is move my x term to the left. So I'm going to subtract 3x and subtract 3x. So that's going to be negative 3x plus y equals negative 7. And this is standard form. Now, sometimes in standard form, they always make the x term positive. So what you may see, all right, in this is that they would just, all right, so if this is ever negative, they would just multiply everything by negative 1. So you would have 3x minus y equals 7. All right, so just depending on how they want this to look, you may see standard form with a leading positive coefficient versus a negative one. All right, so we have done this before. Now, when we look at what we have, okay, and what you want to work with, all right, how do you know if you're right? And the reality is, no matter what form we're in, they should be equivalent, which means if a point is on one line, it should be on the other two versions. So if we go back to point slope form here, what we should realize and recognize is that the point 4, 5 is on this line. Well, if I plug 4, 5 into either of these two equations, it should make a true statement. So for example, if we plug 4, 5 into this guy, so 5 equals 3 times 4 minus 7. So 5 would equal to 12 minus 7. So 5 would equal to 5. So that is a true statement. So we know that 4, 5 is also on this line. All right, so now if we plug it into this, all right, so negative 3 times 4 plus 5 equals negative 7. So negative 12 plus 5 equals negative 7. So negative 7 equals negative 7. So that is true as well. So as you convert from one form to another, you can use this information to kind of self-check, all right, and double-check your work. Okay, so let's look at one more example here. All right, so now notice this time I do have a fraction here. Okay, so when I distribute here, all right, let me go backwards here. Forgot to pull up my writing screen. All right, so I distribute the same way. All right, so y equals, and this is going to be negative 3/4 x. A negative times a positive is a negative. And then negative 3/4 times 4 is negative 3. And then I have my minus 7 here. So then this is going to be negative 3/4 x minus 10. So now we have converted, oops, bad spelling right there. So let me try that again. All right, so slope-intercept form. All right, so now if we continue this and move to standard form, what we know once again is that the x term has to be on the right-hand side, or excuse me, the left-hand side. So I have to add this 3/4 x to both sides of our equation here. All right, let me scroll a little bit so we can see a little bit better here. So I get 3/4 x plus y equals to negative 10. Now, the one thing about standard form is that we never have, okay, fractions as our coefficients. We always want integers. So what I'm going to do now is multiply by my denominator, which is 4, to clear out those fractions. So 3/4 times 4 would be 3x. 4 times y would be a positive 4y. And then 4 times negative 10 would be negative 40. All right, so there's our standard form. All right, so quick review. Like I said, we've done that before. So what I'm going to do now, okay, so here, all right, are 4 different point forms, 4 different slope-intercept forms, and 4 different standard forms. So what I would like you to do, all right, is match these. So for point form, there's an equivalent slope-intercept form in this column, and there's an equivalent standard form in this column. All right, so just to go ahead and match those up, and the same thing for the next example and on. And so notice these are all very similar, and the reason for that is to make sure you're paying attention to your distribution, your positive negatives, and your combining like terms. So go ahead and pause the video, all right, and then try to match up all of the equivalent forms. Okay, so now what I've done is just drawn arrows in for you so you can see how they should have matched up. All right, so hopefully you were very successful. Hopefully you used the fact that we talked about how to check your work, all right, in order to make sure that the equivalent forms matched. All right, so now let's move on, okay, and let's talk about quadratic equations. All right, so when we talk about quadratics, we're really going to talk about 2 different forms, vertex form and standard form. And so part of this is another practice on our multiplying polynomials and different things like that, but it's also to start seeing, all right, different forms of the same type of function, so you realize that, okay, we may have to approach problems a little bit differently if the forms are different, okay, but they may contain the same information, but how you get that information may change. All right, so let's look at something in vertex form. So what we want to do, all right, is change this into standard form. And so standard form is ax squared plus bx plus c. All right, so what we have to do then is basically just follow our order of operations here. So once again, okay, we're going to have to square x plus 3. And I'm going to go ahead and just write that out so that we can see that it's really a binomial times a binomial. So all I've done is taken this square and rewritten it like so. So now we're going to do our FOIL. So x times x, x squared. X times 3, 3x. 3 times x, 3x. 3 times 3, a positive 9, and then the minus 5 stays on the outside. Now once again, before I distribute this 2, I'm going to go ahead and clean up, all right, our inside here. So that's x squared, 3x plus 3x is 6x. Then I have my plus 9, and then minus 5. Okay, so now I need to distribute the 2 to all 3 terms in the parentheses. So that would be 2x squared, and then a positive 12x, and then a positive 18, and then I have the minus 5 here. And then our final step, all right, is to combine like terms here on the end. We have 2 constant terms, so 2x squared plus 12x, and then we have a positive 13. All right, so we have now converted from vertex form, okay, to standard form. All right, so now, once again, how do I know if I'm correct? Okay, so we have our standard form, okay, here, which we just solved for, and we have our vertex form. So once again, all right, what we should be able to realize is that the point, in this case the vertex, all right, much like we discussed with our absolute value functions and things prior to this, is that this is the x-coordinate of my vertex, and this is the y-coordinate of my vertex. So I know from this form that the vertex, or a point on this quadratic, is -3, -5. So if I plug that into my standard form, I should get, all right, a true statement, all right, for this equivalent form. So I'm just going to plug -5 in for y, and -3 in for x, and then I'm going to follow my order of operations and simplify. So -3 squared is 9. 12 times -3 is -36, and then plus 13. And then I have this 18, and then minus 36 plus 13. And then -18 plus 13. And then, so if we just kind of keep working through this, we get to this, and this is a true statement. All right, so what we know is that this point is in fact on, all right, our form here. So we must have done something correct there. All right, so let's look at one more of these. All right. So here we go again. All right, so once again, the first thing that I'm going to do, all right, is write this out as x plus 6 times x plus 6 to remind myself, okay, that I have to distribute 4 times. So I'm going to leave the 1/2 out front and do our FOIL. So x times x is x squared, x times 6 is 6x, 6 times x is 6x, 6 times 6 is 36, and then I'm going to bring down the -12 on the outside. So once again, I'm going to clean up the inside here because I have 2 like terms. So 6x plus 6x is 12x. Then we have the plus 36 and then the -12 here. All right, now we want to distribute the 1/2 to everything. So this is going to be 1/2 x squared 1/2 times 12 would be 6x. 1/2 times 36 would be an 18, and then I have the negative 12 I'm going to bring down here. And then finally, the last step would be to combine these two constant terms here. So 18 minus 12 would be a positive 6. And we are, in fact, in standard form. So once again, if you looked up here, if you wanted to check your work, all right, we should know that the vertex, all right, of this quadratic is negative 6, negative 12. And once again, if you were to take that and plug it in right here, you should get a true statement. All right, so what I'm going to do now is very much the same as I did earlier. All right, a little bit less because now I'm giving you 4 different vertex forms and 4 standard forms, and I want you to once again match up the forms here. And once again, they're very similar, all right, because I want you paying specific attention to how you distribute your positives and negatives, and make sure you pay attention to all those subtle details in a problem. All right, so go ahead and pause the video, all right, and then match those up. All right, so once again, all I have done here is draw in the arrows, all right, to match everything up. So hopefully you did well on this. All right, and this concludes our lesson on working with equivalent forms. So once again, okay, bring in your notes over this. Any questions or any problems that you have, if there's something that you couldn't figure out how to get the right answer to, bring those in so we can discuss. And I will see you in class next time.